the soul, to the Earth also, in particular, the heart chakra, the heart planet of the solar system. This is, if you don't have a copy of my book, I'll give you one today. I think everyone's got one. But so I guess speaking of wholeness, this is a typical globe, right? The way that everyone is used to thinking of the Earth, and this represents an 8,000-mile diameter object, and it's basically a big round rock, as you can see here, right? It's got a real thin layer of water on the surface, and the continents project out of it. And there's apparently this thing called the biosphere, which is made up of plants and animals and insects and microorganisms in the soil. And it's a tiny little layer, just like a mold growing on top of this thing, right? And this is the way people think of the Earth now, right? It's out in space somewhere, and it's floating there, and we're like alone in this vast, huge universe, right? But I prefer this. This is my celestial sphere. And I didn't even know you could get one of these until, I don't know, 10 years ago or something. And I finally checked in a scientific instrument store, and, I bought this thing. And this is, as you can see, it's got the Earth in the center. It's a 3-inch Earth. It's connected by an axis that spans the celestial sphere. And this is the way that people understood the universe about 500 years ago, right? Before Copernicus wrote a book in 1543, which convinced everyone that the sun is actually the center. But before that, we believed that the Earth was the center, not just of everything, pretty much. And the reason why is because, this seems like an arcane, weird thing to most people. I went to school for 20 years, and I never saw one of these in a classroom or a laboratory. Never. It's basically a tool for astronomers, and they use it as a star finder. And what happens is you can set the axis, you can turn the Earth inside this thing, and you can use this thing here to adjust the sun. Along this red circle is the ecliptic, and the white circle, this is the celestial equator. And now we understand that the reason why this works, it's a mechanism here, right? It's more than just the celestial sphere. There's a mechanism, and the mechanism has to do with the orientation of the Earth relative to the stars. This axis points at what's now called the North Star, and it's fixed there. And the reason that it's fixed is because, and we know this now, they didn't know this 500 years ago. We know it because the Earth has a huge mass, and it's spinning in space. So it's like a gyroscope. So it has angular momentum. Hey, wow, people. Nice to have you. Hey, can you all good? Yes. All right. So you're here for the monad thing. Yeah. All right. So I was just telling people, let me try to get you real caught up real quick. So I wrote a book called Metagaia, and it's based upon an app that I've developed with Jim Rodney. He's in the back there. He's my programmer. And we've been working on this for 7 years, and it has to do with this. I use this thing here. It's called a celestial sphere in my app. And I've modified mine, but I'm talking about this is the way that people used to understand the universe. And they imagined that this thing contained everything. They didn't know how big the universe was like we do today. Now we think of the universe in terms of light years. For them, they would go outside, and they didn't have light pollution, so the sky was beautiful. And you'd go outside, and you'd you look up, and if you pay any attention at all, it's not hard to memorize the constellations, to make up names for the constellations, or this one looks like that. And then you start to notice that over the course of a night, the constellations, they wheel this direction. If you're facing south, the stars gradually, over the course of the night, the ones that started over there end up over there, right? The same way that the sun moves, the same direction. And so they were able to they knew this. They knew this celestial sphere. They understood that there's a mechanism. And actually, if you look to the south, you can see the stars moving like a wheel. If you then look back towards the north, it's easy to determine that there's one location where nothing is moving. That's where the axis of this is located. And that's the North Star. And if you were to measure that as an angle relative to the horizon, you'd find out that it's, in our case right now, if we were on a flat plane, that North Star is 39 degrees above the horizon, which is the equivalent of our latitude on the Earth. So it changes, but it never changes in our lifetime. So anyway, I just wanted you to understand that this is a mechanism. We understand it now. If you were to, the way that they would mark this, the ecliptic is by you can see where the sun comes up in the morning, right? It was dark, so you know what constellation was right where the sun is coming up, and you know that's where the sun is. The sun is in that constellation. And you can mark that, and over the course of the year, that sun, you'll see that it rises and sets like this. During the winter, it's low. During the summer, it's high. And that marks the ecliptic. If you follow what constellation that sun is in, you would be able to mark this thing and have this in your head as a mechanism. It's a biological mechanism also, right? Because we know that the seasons are associated with, or the location of the sun is associated with the seasons. It's like the higher it up here, that's summer, and it gets to its highest point, and that's the summer solstice position. And the summer solstice position is very easy to figure out. It's right here. This is the celestial equator, the summer solstice. These are the nodes. This is the descending node. The winter solstice is right there. And then it appears to be ascending right there. So let me show you a monad. You've seen this. This is the way people used to understand that the whole universe was in this. Let me just finish this up. And when Copernicus came along, it didn't make sense anymore. The celestial sphere didn't make sense anymore because this is an Earth-centered celestial sphere. It's still useful as a star finder, but it's not useful as a model of the universe anymore. So it kind of got tossed away, right? They don't. It's useful for astronomers, but it's kind of embarrassing for otherwise because it's associated with this idea that, okay, we thought that the universe was this big, that it was just kind of right out there, that the stars were painted on it almost. Instead of, now we know that they're, vast different distances. And so here we go. Let me set this up. There it is. There it was. All right. Okay. So this is the solar system as we understand it today. These are the orbital pathways. This is here. I'll show it on here. I can. So this is Pluto. This is Neptune. This is Uranus. You can zoom in here a little bit. Here's Saturn, and Jupiter is that one there. And what I've done is I've modified this celestial sphere. I still use it because it's that mechanism is essential. It's essential to the calendar clock because where the sun is along the ecliptic from an Earth center perspective is the date indicator. It's like at the equinoxes, those dates are fixed. Our civil calendar is fixed relative to this celestial calendar so that it doesn't migrate over the course of it used to migrate. We used to have we've got an algorithm now which is 365.24219 days exactly. It used to be well, I mean, it's taken a while to develop this. At one point it was 365.25, and so over the course of hundreds of years it migrated like 19 days. So they had to have this year where they added in all these extra days, and it's called the year of confusion. I think it was actually about 90 days that they added in. This was back, when was this, Thomas? It was a long time ago. It was, no, it was early Rome. I think it was around 1400s, 1500s. And then they had to do it again when they adjusted the mechanism one more time up to 365.2425. So they add these days in because it keeps the civil calendar associated with this. So, but my celestial sphere, the one that I'm using in Monad, here it is. It actually has a very precise size. So it's no longer the size of the universe. It's 2 astronomical units. An astronomical unit is the distance from the Earth to the Sun. So that's the radius of this celestial sphere. So the diameter is 2 times that. 2 times, and 1 astronomical unit is about 93 million miles. Now it's not a fixed number because Earth is orbiting in an ellipse. So it varies between 91.4 million miles and 94 point something million miles, or an average of about 93. So this celestial sphere, it actually, if as a mathematical object, it actually is adjusting in size to reflect it. The sun is always on the surface of this celestial sphere centered on the Earth, which means that as this, let me show you what happens here. As you accelerate forwards in time, now if you look here, the Earth is rotating this, hold on, let me go back. So here, I'm going to zoom in a little bit closer. This is the hour hand. And if you look here, you're looking at North America here. And at the base of this hour hand, there's a little green sphere. I don't know if you can see it on there. The resolution is not that great. But this is covering 15 degrees of the Earth, and it covers the time zone. So there's 24 time zones. 15 times 24 would circle the Earth here. This right here is the north polar axis, where the Earth, the spin axis of the Earth. And so you're looking at the Earth from an unusual perspective. Usually you look at the Earth like this, right? But you're looking at it like this. And so this is the celestial equator. If you project the Earth's equator out into space, that's the celestial equator. The number dial is inside there, and the number 12 is always associated with the sun. Wherever the sun is, that's noon. So this is spinning when the hour hand is pointing directly at the noon. In other words, you go outside, you'd see the sun is directly overhead at that time, right? So now watch what happens here. This is current time here. So we can't see the moon. If you go outside, you're not going to see the moon. It's way over here. if you had a telescope, you'd be able to find Saturn pretty easy, and I think that's Uranus right there. So I'm trying to do this here. So let me just accelerate forwards in time here. So this is the direction that the Earth is spinning. You're looking at the North Pole, and from that perspective, the Earth is spinning counterclockwise, which is rather inconvenient actually, because it required us to put in a counterclockwise number dial, which some people find very off-putting, you know, but there's not much we could do about it, you know. So if you go around to the southern hemisphere, it goes clockwise. So I mean, you could always move, right? But here we are. So, and you can see here's the moon. The moon advances 13 degrees every 24 hours. So it's 15 degrees from one hour to the next. So about 1 hour it advances. You can speed it up. And all of this is taking place on a very tiny scale for the solar system, right? Here's the solar system, Pluto, and we're in there, and that's where the celestial sphere is. And I'm gonna bring in the planets. It's hard to see everything at that scale, but on one end you can hit this button, and all the planets, their orbital pathways, we shrunk them in. So the data is still based upon their location actually on the real orbits, the elliptical orbits. But we brought them in here so that you can kind of get a sense of everything together. This is the solar system like this. I'm going to speed this up. Now, as you can see here, it's pretty inconvenient to try to read the time and date in this heliocentric perspective. So what we did is we built this in an environment where you can move the cameras around. So we just moved the camera so that it's focused on the Earth in geo mode. And there it is, right? So now if you look here, this is what it looks like. Speed it up. Let's not speed it up that fast. I want to show you back and forth between helio and geo. The underlying activity is the same. It's just where the camera is located. So the camera in this case is focused on the stars. The camera in geo mode is focused on the Earth, maintaining a vertical orientation with the sun at the top of the dial. And what that does is it accounts for a solar day is different from a sidereal day. A sidereal day is the time it would take for the Earth to spin once relative to the stars, but then the Earth advances about 1 degree, about 4 minutes. So a sidereal day is about 4 minutes less than a solar day. So, and this is, we added these, the full planetary dial within the past year and a half, changed the colorization here, fixed the appearance of this, added the stars in the background. We didn't have the stars in the background there. We had them inside here. And so let's hit this back to geo. There it is, and you can see inside. You can see the constellations. The stars that are pointed out there are the same ones that are out here. We just have two different ones. One is from the perspective inside. We added the lines of the constellation because that's what they appear to us inside the celestial sphere as constellations, which is useful because they are part of the time and date telling apparatus of the solar system that we happen to find ourselves in. And now this poster here is the same as the cover of my book. And in this book, I talk about the significance of this structure here, this celestial sphere, as I was telling you at the beginning of this, is a model of wholeness that is missing from our society right now. And it's like this is not the whole universe anymore, but it is a whole something. And what this is I am convinced that this is actually, that the Earth is what I call the heart planet of the solar system. I believe that the solar system is a living organism, and that the Earth, this heart, or this organization here, this chakra organization, is an indication of how the heart has a form and functionality. It's like, if you look at this, it looks like there's empty space here, right? But actually, inside of this, there's all sorts of things. For instance, there's a magnetosphere inside, right? This Earth has a magnetosphere, and a magnetosphere is here. I got a picture. There it is. This is the Earth's magnetosphere here. It is not. It doesn't coincide with exactly with the North Pole, but it's fairly close. And it's a torus-shaped thing. In other words, like a donut. So, and this, if you Google this, you'll find out that this thing is about 10 Earth radius, so about 5 Earth diameters out, which is not that huge, right? It's certainly not big enough to fill the celestial sphere. But also, this actually doesn't have a skin like an apple has a skin, right? It actually extends off into infinity. So it does fill this space in a certain sense. And just while I'm on the subject here, this celestial sphere, if it's 93 million miles in radius, it's 186 million miles diameter. Now, 186 million miles, that's a very curious number, right? Right? I mean, what is the speed of light? The speed of light is 186,000 miles per second. So if you think in terms of it's like a light year it's not a period of time, it's a distance. So a light second is 186,000 miles. So if this is 186 million miles, it means that this is actually 1,000 light seconds in diameter. Now, is that a weird coincidence or what? Right? Because it's in other words, it's useful to use as a measuring like a yardstick. Right? A yardstick has, it's whole. It's here. That's it's 3 feet long, but that's what it is, right? And then you use that to measure. There's 40 of them from here to there, right? So you can use this also in celestial calculations. You go back here. Well, it's like this is 1,000 light seconds. It takes, for instance, it takes 500 seconds for light to travel from the sun to the Earth. 500 seconds, that's 8 minutes. 8 times 60 is 480, 20 seconds, right? So anyway, it's just an interesting thing to consider. So this is filled with a magnetosphere, and it's also filled with an atmosphere, because the biosphere of Earth is, the Earth's biosphere, let me show you this poster here, is predominantly a plant-based biosphere. And 83, if you were to measure it, the biosphere is made up of all the plants and animals, any living organism, if you were to weigh all that stuff somehow. I don't know how they did that, but somebody figured it out. they figured out that 83% of the biosphere is made up of plants, 16% is made up of microorganisms in the soil, which allow plants have to extract certain organisms like nitrogen from the soil, and these microorganisms make that possible, this communication between the plants and microorganisms in the soil of the surface of the earth. And then this little tiny box here is 0.5% is made up of animals. And here, arthropods, fish, humans are this tiny thing right here in the corner, so that little bitty lip right there in the very tip. Can't even see it, right? That's us. Well, the atmosphere, there are birds in the atmosphere and there's insects, but they don't contribute to the biomass. Now, that's just one definition of the biosphere. Another definition of the biosphere is any part of the ecosphere or the geosphere that is involved in, and it's like you could draw the line wherever you want to. It extends into the earth in a certain sense and into the atmosphere. But the point is that it's mainly photosynthetic. So being able to here's the globe that most people are used to thinking about, right? This thing here, this isn't whole. This is just a broken part. This is, it doesn't, this is whole and this is whole because you've got the sun, the earth, and the moon. This is all a part of a mechanism of life. So let me show you another thing. The poster talks about chakra mode. Now, this mode here is focused on this celestial equator. It's like you're looking along the camera is fixed along the axis in a certain sense. Now, for chakra mode is this idea that in a body in particular, a body has an orientation. It's got a top to bottom orientation. It's got a left to right. It's got a front to back, and it's in time. It's breathing. It's doing something in time. So this, as a chakra, has a correspondence across scale here. And so here is chakra mode. And what I've done is now it's like, if you look here, it's this ecliptic, which splits this thing in half. It's like the ecliptic in a human body is the midline. It divides the left from the right. And the top to bottom, the sun, is the equivalent of the brain of the solar system. The earth is the heart chakra, and this is the container for something. What is that something? I call it the heart chakra, but it's not just the heart. And this gets into something very interesting, because what is the heart? People say that the heart is just a pump, which is kind of a, if you know anything about hydraulics, or the viscosity of the blood is thick, and the idea that the heart is pumping this fluid through these tiny little channels, which have incredible resistance, it's impossible. It can't happen. And my understanding of the heart is that the heart is like, let me show you this. This is called an aeolipile, and it's an organization. It's like, this is a metal container. It's filled with water here. This is a spinning ball here at the top. This isn't a very good picture, sorry. But if you heat this up, this water starts to boil. It releases air, which is compressed hot air. It comes up into this chamber here, and it goes into this spherical chamber with these two escape valves pointed in a different direction, and causes it to spin. The idea is that it's the arrangement of the elements, the four elements in a body, which creates a motor, life, in a certain sense. And it's the arrangement of the sun, earth, the water, and the atmosphere within this thing, which has a similar, if you flip this upside down, I can't do it. So you'd have fire. This would be the earth down here. The sun here, air and water would fall out down into that, and it's the same sort of thing. But this arrangement here is for a photosynthetic organism, as opposed to we are animal organisms. But what I'm saying is that the magnetosphere and just it's like if you get into quantum physics, they talk about David Bohm has this theory of the implicate order, this idea that there are no separate parts or objects in the universe. Everything is part of one undivided whole. Actually, you have to work your way back from the whole back to the part, and that part is actually it is the whole in a certain sense. The whole is in that part. It's enfolded into that part. And then he also talks about a pilot wave theory, where it's like each particle at any level is emanating this field of information around. And so I'm convinced that the Earth is emanating this field, that the magnetosphere is a subtle manifestation of that field. And then the Earth itself is a less subtle manifestation of that field. And the whole thing is connected by the flow of plasmas from the sun. And it's, in other words, this looks empty, but it's not. There's tons of information in here about the form and functionality of this as a photosynthetic organism, and our human bodies are immersed in this field, this morphogenetic field, which allowed us to generate a body that mimics the same functionality, except as it uses a complementary physiology, photosynthesis in the solar system body versus animal respiration in a human body. So if you look here, this has two trees, right? And these trees, this one represents the light phase of photosynthesis. This one is the dark phase of photosynthesis. And this right here, this line separating the light from the dark half of Earth, is called the circle of illumination. And this is a key element of the monad calendar clock, because when the hour hand reaches there, that's twilight, sunrise or sunset. But let me get back to this. So the light phase of photosynthesis, light from the sun interacts with chlorophyll in plants, generating ATP. And then the dark phase is where plants use the ATP molecule, which is basically like a battery. It's like every cell in any body on Earth, whether it's a plant or an animal, uses the same ATP molecule as a battery. It's like, imagine that your body, all the cells are using battery-powered molecular mechanisms to operate. They have to plug in a battery to operate that mechanism in the cell. So
derivative of glucose? ATP is a derivative of glucose?
Is what a derivative?
ATP.
A derivative of glucose. No, it's not a derivative. It helps assemble glucose molecules. It's like plants eat. What do plants eat? They don't eat from the earth. They don't get anything from the earth except some minerals. They eat like a whale eats plankton, except they're fixed, so they have to wait for the currents to bring the air, which contains carbon dioxide, which we happen to exhale. So we have this complementary relationship with plants. And so they take in carbon dioxide, and down here in this thing here, they use that carbon dioxide with the assistance of ATP to generate glucose and starches and all the other material which goes into building plants. Now, in our human bodies, this circle of illumination is equivalent to the diaphragm. And this container is the pleural cavity for the lungs, and the peritoneal cavity for the digestive cavity. Basically, the torso is made up of the heart, lungs, and digestive system. And it has this organization. It's like we breathe in the oxygen that plants produce in this light phase of photosynthesis, right? And then we also take in food and use it. We break it down into materials, basically, that get distributed to the rest of the body, like plants building up their, it's a complementary organization. And I'm convinced that all of the planets have significance like this in terms of they have an operation. Maybe they don't have DNA life forms, but they have energetic patterns which contribute to the endocrine circulatory organization of our body. So this is the thyroid, this is the thymus, this is the spleen. Jupiter is the solar plexus, which is the adrenal medulla. There's the kidneys, and these three altogether are the urogenital organs of the body. And in my book, I talk about, I speculate about, correspondences across scale. And
How far up is the magnetosphere of the Earth span?
well, they say it spans 10 Earth radius, but like I said, it doesn't have a shell. It expands out forever. It's like everything kind of expands out forever. With this, according to Bohm, it's like there's matter has a wave that's enfolded into it out to kind of everywhere. It's a very bizarre theory, but wholeness kind of demands it.
The other planets, most of them have magnetospheres.
All of them have magnetospheres except for Venus and Mars. And I think that I have this theory called cosmic recapitulation, which, if you've heard, recapitulation is the idea that organisms follow the same stages of evolution based upon their embryonic development in a certain sense. And so we think that these planets, Mars and Venus, at one time had magnetospheres, and that they, for whatever reason, they went away. And the thymus and the spleen are both organs which are essential for early childhood and development in the womb. They make, one of them makes blood, and they do all sorts of useful things. But by the time of early adulthood, you don't need them anymore. You can lose your spleen. People get in car accidents and they have their spleen taken out. They do fine without it. And same with the thymus. You can get by without a thymus. And I think that it's part of the, if you were to look at the evolution of the solar system, you would see how it evolved in a way which parallels our development from a single cell organism up to this body. That it somehow recapitulates all of the changes. It's like the solar system. I also believe that our solar system at one time was a binary system, and that these outer planets, the gaseous giants, were part of this, like a second sun, with a ratio of like 96 to 4% mass. So it had this, like an undulatory motion, very much like a primitive organism. And then it somehow evolved into this over the course of, we're talking billions of years here, right?
Divided. Like cells divide.
Yeah, it divided. It's like this is a cell, right? This was their intuition, is that this is a cell. Mm-hmm. And now I'm saying that it's not a cell, it's not the whole universe, but it is a container. It's an organ system in this solar system. The solar system is a living organism. Earth itself is not an organism. It's an organ system. It can't exist without the sun. the moon, and all these other planets are contributing to the physiology of this being, right?
So if an alien came along and blew up one of these planets and screwed things up.
Yeah, it would probably be a bad thing, actually.
Are you saying that like that influence in the physiology is somewhat like dictated by the solar bodies? Like in that, like if they weren't there, we wouldn't have one or the other.
Yeah, exactly. If we had a different, in other words, it's like we're out there now looking for life on other planets, right? And they're looking for Earths that fit a particular criteria, right? They have to have a three-phase hydrosphere. They have to be close enough to the sun, and theoretically, they should also have a moon. You know, we've got some very strange coincidences with our moon being the same size in the sky that you can have eclipses, and I think that that's important. So, yeah, I think that we should be looking for solar systems that can support life, not for planets. It's like, theoretically, you know, we're never going to find another one that has this exact organization of planets, right? So maybe the whole idea is kind of wacky a little bit. I mean, it's fun for billionaires to play with, but yeah, it's exactly right. It's like the creatures that arise on the heart planet are going to reflect the organization of the solar system as a whole, is what I suspect.
I don't know if this applies to what you're saying about recapitulation, but I read someplace that when the sperm and the egg unite and the thing begins to grow, it recapitulates evolutionary development. So it takes on the form of a fish and it
Yep.
takes on the form of
Exactly.
higher level.
Yeah, I'm saying that we follow the organization of the solar system also, not just the organization of other species, but also it's like we are the solar system. It's like you look at this, and I identify with this. It's like the solar system is a great man, and man is a small solar system. This is a saying which is ubiquitous in religion, right? We are made in the image of God. This is what they keep telling us, and I think that you know, I wouldn't claim that this is God because, you know, it's like, I don't know if you've heard of a woman named Lynn Margulis. She was married to Carl Sagan. She's a biologist, a fabulous biologist. She wrote a book on the origin of eukaryotic cells, and she talks about how eukaryotic cells are made up of they engulfed a bunch of prokaryotic cells, which are much more simpler cells, but some of them were photosynthetic, and those turn into different organelles in the body of the cell. So even cells are recapitulating, right? And your body is made up of eukaryotic cells, you know? And also, it's like, why do we have this organization of our bodies, right? I mean, it can't just be a random occurrence, right? It's got to have some rationale that we have two lungs, two, you know, the division here is, if you look at the light strikes the planet. Let me show you on this. So here you've got the sun illuminates half of the earth. That's a circle of illumination right there. And it heats the water. The water, heated water, turns to vapor, rises up into the atmosphere. And then, let me go back here. I'm going to slow this down a little bit. So it then carries this, it transports the water that's being evaporated, gets carried to the opposite side down here, where it's cooler, where it condenses and falls as rain, right? So it's a circulatory system. It's the archetype for our circulatory system. You know, I mean, there's, you know, certainly there's a lot left out. You know, we're the arms and the legs, right? And all the, you know, it's like, but you have to think in terms of morphogenetic fields first organizing the central body, and then work your way out. And I haven't made it all the way out yesterday.
Are you saying there are direct correspondences between planets and organs of the human body? And so, can you give an example?
Yeah, the direct correspondences. Yeah, this is Jupiter, and Jupiter has a correspondence with the adrenal medulla. Now, the adrenal gland is famous for it secretes adrenaline, right? That's the adrenal medulla, and the adrenal medulla is a very unusual tissue in the torso. It's actually nervous tissue, and it's directly connected with the brain in a certain sense, and it has a cortex which is divided into 3 layers. And the 3 layers, one of them secretes aldosterone, the other one secretes cortisol, and I think the third one secretes gonadicocorticotropics, or I don't know what it is. But what's interesting about Jupiter is that Jupiter is a gaseous giant. The sun is also a gaseous giant, which is ignited and, is now a sun. And Jupiter has, I forget how many satellites, but a lot of them, and they're arranged in 3 different layers. I think there's 7 in the first layer. The first layer, they're moving prograde, so they're moving in the same direction that this is, and they're all in the celestial equator, the plane of the celestial equator. Then there's a second group of planets, which are they're also going prograde, but they have a very pronounced tilt relative to the celestial equator. They're further out, so they don't run into each other. And then the farthest out layer of these planets are actually moving retrograde, right? What are the chances, right? I mean, it's like, I know it's just, okay, it's just a coincidence, right? But there are coincidences associated with all of these planets, I suspect. And we're just now beginning to dig into these planets. I mean, they're really hard to study. They're a long way away. So everything we know about them is based upon, light reflections, and now we do have satellites that are studying these things now. So we're getting more information about them. But I think that this would be a useful model to try to see if it arranges the way that we approach studying these planets.
But also, astrology ties into this.
Yeah, doesn't it?
People think that it's myth, but it's not really myth. It's based on hard science.
Yeah. This is, in fact, we are where I'm at here. I'm going to answer your question, but first I want to get Thomas up here.
Okay.
And Thomas, we've been working on this thing together for a long time, and I can't say enough about Thomas. He's great. I know but he basically drove the development of the precession that I want him to talk about. So precession of the equinoxes, it all applies in here. Let me just finish up one more thing. So there's 4 main biorhythms to consider. The solar day, which is the rotation of the Earth relative to the sun. The lunar month, which is the rotation of the moon around the Earth, going through its phases. All of these have an impact on the light being delivered to plants on the surface. And then the seasons, the tilt back and forth, changes the amount of light over the course, like during the winter, you can have, depending upon your latitude, you can have 8 to 10 hours of daylight, versus in the summer, you might have 14. So that's a lot more light. And that's another rhythm which I call the swara, which is the alternation of sympathetic and parasympathetic activity in the body. Is a correspondence, because all of these have to have a correspondence. The solar day is the heartbeat. One solar day is one beating of the heart. The lunar month is the breath. Inhale, exhale, inhale, exhale. And the precession of the equinoxes is the lifetime of an organism, or of a species, is what I suspect it is, actually. But anyway, it's a 26,000 year cycle, and it's really beautiful. And anyway, Thomas is going to tell you more about it. Yeah.
You just mentioned about the cycle of the heart, the one lunar cycle, and then the
Solar day.
the head. I'm curious if when one is out of regulation, right? Like there might be like a format, right? Like the lunar cycle of, say, the lungs in the larger picture of the solar system has a dictated pattern, but you might find a human being having the experience of regulated breathing, right? Like where it's not, it goes up and down and it's not consistent.
Yeah, it's not.
But I'm curious if if you're in this theology, you might be suggesting that like there's a pattern that one might like try to align with the body.
That's a good question, right?
Within the solar system.
Yeah, I mean, you can use this. I've set this trying to link up the moon with my breath, for instance. Right? Let's, like, here we go. So it's like, this is the exhale. Now we're starting the inhale. So that's too fast, right? So you gotta slow it, or you gotta, but it's like, okay, so that's like a meditation device. But their correspondences, because the physiology is the same. It shares the same morphogenetic field, so it's going to share the same biorhythms of that morphology, the organ systems that are developed. But humans, it's like, this is extremely regular. The 24-hour day, the lunar month is almost, is 29.51 days, 24 hours exactly, pretty much. And the alternation of the seasons is also very regular. Whereas in a human body, for instance, the alternation of the seasons is equivalent to this, it's a rhythm called the swara. And I heard about this swara, I found this book, Swara Yoga, the tantric science of brain breathing. And it is based upon the idea that if you breathe onto the back of your hand through your nostrils, you'll find that one nostril is open, either your left or your right side is dominant. And this book talks about how if you want to be successful in life, you do certain activities when your left nostril is open, you do certain activities when your right nostril is open. And we have the ability to change that. This solar system can't do that, right? We can change ours, and it has a lot to do with eating. It's like sympathetic activity, or eating is a parasympathetic activity. So when you eat, you then need to rest. And after you've rested, you're in Ida at that time. And then at a certain point, you've rested enough, you feel, okay, I'm going to be active for a while. So you get up and you're active, and that's Pingala. And you should find, you breathe under your back of your hand, and your right nostril should be active here. And then you get hungry again after a few hours, and you go back and you eat. And so there's this alternation of sympathetic and parasympathetic throughout the activity, throughout the day. And then sleeping is Ida. The whole day period is Pingala. So there's all these rhythms within rhythms, right? And it's just, I mean, that's a rhythm that people should know about.
Right. There's also a yogic tool called a Hamsadana.
Exactly, the dandas.
Short crutch that you put under one arm or the other, and that I think it's if your left nostril is dominant, you put it on your left armpit, and it shifts over to the right, and you can alternate the tool back and forth to balance your breathing.
Right. And also, it's like if you find yourself, okay, a teacher just showed up and I need to go meet with this guy, and yet I'm in my Pingola. I want to be Anita when I go to this guy. So you then put the thing underneath there and you can switch over. Or you can lay down on your right side, and there's different ways that you can do it. It's such a deep thing, they talk about being able to predict the sex of your child, and just everything is related to this in a certain sense. But let's get Thomas up here.
There was something you mentioned to me, there was a question earlier about, like if we grew up on the planet would not change their physiology.
Yeah.
You mentioned that there were 2 planets that don't have magnetospheres here.
Yeah.
And I remember you correlating it with some organs that have changed or something.
Well, I mentioned that Venus and Mars are the 2 without it, and they are related to the thymus and the spleen, and both of those organs can be removed in a body. They were useful. They were necessary actually for the development of the body up until a certain stage, and then after that they no longer were necessary. And I suspect that cosmic recapitulation-wise, this at one time had fully functioning magnetospheres for all of these things. And then for whatever reason, at a certain time, they lost it. In maybe 1 million years ago or 1 billion years ago or something, right? And so that is some support for the correspondences between what I'm looking for with the planets and the organ systems. And the this is also releasing plasma, which is flowing down in, and it's like you've got alternation of the fields here, creating that caduceus sort of the depiction there.
Do you think there's a harmonic resonance between the solar system and the
I think that this is what I'm going to talk about after Thomas gets up here, is our next thing that we're going to work on is this thing I call the calendar clock radio. This is a monad calendar clock. And the radio is, what we're going to do is we're going to assign a tone to each of these planets. And then you can modulate that tone based upon proximity to this, thing here. It's like, it's complicated. I'll talk about it. Let's get Thomas in here. This is really cool. You're going to want to see this.
And just another thought on the idea of what if you blow up a planet, there is the asteroid belt, which is between Mars and Jupiter. And, one of the ancient stories is that there was this war between the gods and one of the planets got blown up. Right? Planet Tiamat, I think, is one of the names for it. But just recently, astronomers found a massive asteroid that in the, whatever astronomical newspaper, they called it, that it appeared to be like a chunk of a center of a planet, or a remnant of a center of a planet, which to me was just confirmation that it used to be a planet. And I would suspect that if we find all these correlations, that there is possibly an organ somewhere between Mars and Jupiter, maybe the appendix. I don't know. Something that evolutionarily used to be important, and now it's just like basically gone. It's like non-functioning. The only one I'm aware of is the appendix. But, so, we spent a lot of time building this, and to me, the center, like inside the celestial sphere, has always been kind of this. Oh, I kind of want to go in there, and it's for a long time it just kind of felt like we could go in this far, and that's kind of it. Well, so finally I convinced Keith that what if we just go inside there, and then suddenly it closes in, and we can actually look around inside the whole celestial sphere. Oh, thanks.
By the way, that's Jim Relke. He's he's who I first worked with. He built the first 3D model and then animated it, showing the sun moving back and forth on the moon track. And that was, what, 8 or 9 years ago?
Yeah, but you guys have just taken this whole.
So let's see, there were only a couple things that I thought about talking about with this. So probably the most obvious one is, if you're familiar with astrology at all, there's Western astrology and Eastern astrology. And there's kind of a bit of confusion around the fact that we have these things called the zodiacs, and then we have these things called the constellations, and maybe the names are kind of referred, you can kind of use one name for the other, and they're in different places. And so we can see that right here. It's kind of hard to tell here with the detail, but this is an example. Yeah, so the sun currently is, I think it's Sagittarius is the zodiac. Is that right? Yeah, we're Sagittarius right now. So people who are Sagittarius, this is your time. And then, but interestingly, the Scorpius is the constellation that's currently where the sun is currently in the constellation of Scorpius. And so the idea is that approximately 2,000 years ago, when the zodiacs were fixed, zodiacs are in relation to the spring equinox. So technically, they're just 30-degree sections of the sky. We could call them 30, 60, 90, but it's a lot nicer to have names. It's just that the names correspond with the constellations that were there at that time. But the Earth, as it spins, the Earth is orbiting around the sun. If you're familiar with a spinning top also does this kind of movement, or maybe it's this. Mm-hmm. But I think the Earth is doing this wobble, and it takes 26,000 years for this wobble to do one turn. And what this means is that the consequence of this, because our whole coordinate system, our whole kind of relationship with the sun is based on the spring equinox, and our Western zodiac is a seasonal zodiac or seasonal. It's basically a calendar. In some ways, you could call it an astronomical calendar, but it's completely based on the spring equinox. But because the Earth's tilt is changing, the spring equinox is just an orientation between the tilt and the sun. So as the Earth's tilt changes, the position of the Earth in relation to the sun and the stars changes. So it actually means that if this is our orientation now, in 13,000 years, the Earth is actually going to be on the opposite side of the sun at spring equinox. And so you can kind of imagine that over 26,000 years, the constellations are shifting, and so we created this visualization to demonstrate that. So where is the sun? Okay, so there's the sun. The sun, what we've done is we basically frozen the orientation of the Earth and the sun at spring equinox across time. And so now when we accelerate time, we're just seeing still the spring equinox orientation, but we can now see the constellations are slowly moving in relation to the spring equinox and in relation to the 30-degree or the zodiac, aka the astronomical calendar. Our calendar is actually rotating in relation to stars, but because this is Earth-centric, we're looking at it from our perspective, it appears that the stars are moving. So one interesting thing about this, and this glowing bar is basically just showing that, the sun is actually moving back and forth very, very, very quickly, but we just want to keep everything kind of still. One interesting thing we can do is we can go backwards in time here. And if our understanding is correct, about 2,000 years ago, the constellation of Pisces should align with the zodiac of Pisces, and that's exactly what we see. Is that approximately 2,000 years ago, this is our relative time. At approximately 0, there's Aries constellation, Aries zodiac, etc., etc.
Were you using the word constellation and zodiac interchangeably?
No, the way I'm using them is the constellation is the actual star pattern, and then the zodiac is the 30-degree, the sign, right? Yeah, the sign of the zodiac.
And so now there's a differential because of that model, but it's a very minute differential from a human point of view. Where
Human
if you're
lifespan.
looking at a bigger scale for some reason, then you can see why they don't match anymore.
Right, but we don't see it changing, but we do notice like, oh wait, Aries doesn't line up with Aries anymore.
Right.
Which is like in our little tiny slice of time, it's like, humans did that 2,400 years ago, but now we're seeing the consequences of it.
Right.
Is
It's
it,
enough to see after a couple thousand
Right.
years.
it's the age, right? I mean,
So the age is an
Yeah.
interesting concept, right? Like there's this idea that we're in the age of Aquarius, we're about to enter the age of Aquarius, we've been in the age of Pisces. And so one of the interesting questions is like, well, how there's not really an agreement on precisely what that moment is. So Keith and I have come up with a very precise astronomical definition for the beginning of the age. And it's based on this star called Regulus, which is one of the brightest stars in the sky. And a really interesting thing about it is it's right on the ecliptic. And so as precession happens, or even just as the stars rotate through the sky, this bright star is exactly on the ecliptic. And it's one of the few stars that is. Where is it?
So it's sort of a fixed point on the, in a sense,
Yeah,
marking the ecliptic.
it's a convenient star to use. And what's also interesting about it is at about the time that the signs were fixed, it was incredibly close to one of the boundaries of the 30-degree boundaries. And so what if we actually just consider that to be the indicator of the age? And we can see it right here. It's in the constellation of Leo. And it's a very bright star. And at around the time that the signs are fixed, it's very close to the north quarter of that sign. So we could just say, why don't we just consider that to be the age mark? An interesting consequence of that is that if we zoom forward to now, and we can just hit our now button, you can see that we're almost precisely aligned with, right, and we added these little vertical lines that signify the
30-degree.
the age lines. So those little age lines move. And if we look at now, as we approach now, that green line is approaching our Aries boundary, which is our age boundary. And it turns out that if we use Regulus as the indicator, we entered the age of Aquarius exactly in the year 2012. So maybe the Mayans were onto something. Yeah, maybe they were on. I don't know. Or maybe there was some prehistoric usage of Regulus as an age marker. Why is it called Regulus? Does it regulate
Regulator.
time across thousands of years?
More coincidences than coincidences.
And then there's another question, which is, it's in the constellation of Leo. And the constellation of Leo looks a lot like the Sphinx in Egypt. I just don't need to accelerate this. Rotate it. Where is it? Yeah, so, here's the constellation of Leo. It looks a lot like the Sphinx. You got this big body in the back, head. The Sphinx is positioned precisely facing due east. So, it could just be about the sun. That's where the sun shows up on the spring equinox. But what if it was built at the time when Regulus was precisely on the spring equinox? We can try this idea out. What if we go backwards in time until Regulus aligns with our spring equinox? It's approaching. Yeah. So they were kind of there. That's about 11,000 years ago. And so there's a bit of a controversy around the Sphinx, around questioning what time period it was built.
I've heard that as coming up.
The current kind of, the dominant narrative is that it was around the same times as the pyramid, 4,000 years ago-ish. But there's a lot of evidence, water damage, and evidence that there was actually standing water. So that places it a lot further back in time. Graham Hancock is probably the most well-known person who's raising questions about it. But this to me is an interesting, more cultural, circumstantial evidence that maybe it was further back. So those are the only things. Oh, no, wait, one more thing that's interesting about this, which is, when Keith was talking, he was talking about true north, and then he said, that's Polaris. Interesting thing about Polaris is that's true north right now. But I was having a conversation with a friend, and we were thinking, when did we start? When did this idea of true north even come up? And it's all about navigation. We think of it as a navigation tool. Well, the Phoenicians are the earliest known people to use the stars for navigation, and they were approximately 4,000 years ago. But if we look up here, we can see the axis of the Earth pointing at the sky, and that's Polaris right there. If we go backwards in time, Polaris very quickly rotates away from true north. True north is where the North Pole points. We're only at 1,400 years ago, and if we keep going back to approximately the time of the Phoenicians, Polaris is so far away that it would not really have much relevance as a navigational aid. And in fact, there's not really, any particular star that is obvious. You have to just kind of know the layout of the stars in relation to true north of that time in order to navigate by the stars at that time. So that's an interesting consequence, or just and there's this idea that the star Vega will become the North Star in so many thousand years. And you can just kind of see how that's true here, just by turning the thing on and seeing the stars move around and seeing how true north is. This is a different way where we've now shifted to Earth's coordinate system, the geocentric coordinate system, and you can see how the stars over time are just kind of sweeping past true north. That's all. That's all I got to share.
Thank you. Really cool.
Yes.
Beautiful.
Thank you.
Polaris is part of the, is it the Big Dipper constellation or this?
Yeah, the Little Dipper. It's the very end of the handle.
Thank you, Thomas.
Thank you.
Yeah, this was missing in Precession here. Anyway, I think that this view in particular, I just get a kick out of this. Look at that.
Yeah.
that beautiful? I mean, this is not in precession now. This is what the sun appears to us to move through these constellations in the course of the year. So that's the winter solstice, spring equinox, summer solstice, fall equinox, right there. Yeah, I mean, this is a year and every 4 seconds or something, right? So yeah, we're hauling butt. And I don't know. To me, this feels like being in a cathedral. It's like a holy place, you know, inside there. So anyway, I guess I wanted to finish up talk about what's upcoming is the radio, and I'm really excited about that because with both Thomas and I, or I should leave that on. Are not exactly big fans of astrology. You know, I mean, I like to think of myself as a scientist. And, if you're a scientist, you can't believe in astrology, right? It's like I tried for years to get Alan Stoller interested in this. I showed it to him, and he saw the signs of the zodiac, and that immediately just like, this guy's a wacko. That's my interpretation. I don't know what he thought, actually. But I know that we use the signs on the outside here because they have to do with their time-telling devices. The sun is in, what is that, Sagittarius?
Yeah.
Is that Sag? Yeah. And that means something from a seasonal perspective. But it also, I keep turning it off.
What units of time are being measured, like seconds, minutes, hours, days, weeks, months?
Any of them.
For what?
Any of them. All of it. Yeah, you can select either, any.
Yeah. But I guess the more I came up with this understanding, and especially the idea of the morphogenetic fields, and each planet has a morphogenetic field which gives rise to an organ system, then it made sense to me that the orientation of the solar system is, it's like how close the star is means that it's easier to read the information associated with that event at that time. It's like as the sound on a radio. It's easier to figure out the sound if it's closer to you, right? So we're gonna generate this thing so you'll be able to. There's also a 2-dimensional version here. I clicked the 2D, and this is useful because you can drag this. If you drag the middle, you're dragging the hour hand. You can drag the calendar band at a fairly slow rate, or the zodiac band once per year. So the idea is that this up here is going to be turned into the equivalent of a equalizer on a stereo. So you'll be able to, you'll have different settings where you can adjust the volume, and you would enter your birth date because your birth date will determine the setting of the volumes. And then you can select the period that you want to hear, right? So I want to hear the next week. So I would set this to the now, and I would run this thing through for a week. And as I drag this, it would start to make sounds. Or whatever, right? And that sound would be different for each person based upon their birthday. It's called the music of the spheres.
Is that for fun, or is it that you're actually investigated natural frequency for
It's
particular bodies?
It's based upon the idea which has been around since the Greeks were talking about this. The music of the spheres. It's like Pythagoras experimented with tones and strings. He worked out harmonics, and you divide the string in half and all this stuff, right? And so they speculated about the planets. So if we assign a tone to build an octave over the course of these planets. Then their volume would change relative to your birth location, but also there would be like flat, sharp as it's moving away from the sun. It gets flat and then it sharpens on the way back up. Or something, there's different ways to modulate sounds.
There's so many possibilities. Right. And really, one of the fun ideas is to give you the option to say, do you want it to be sharp or flat, or volume up or down?
Yeah.
Yeah, that could segue into a completely other possibility. I mean, I'm seeing, app after app.
I know, right? It's an astrology program, but it's an astrology program without any words, right? It's just, you just listen to the sound and you get what you get from it. Does it sound chaotic to you? Because I can't wait to have this thing and to try it out. Do it over the period of the World War, right? What did it sound like then? Does it sound different?
You're bypassing the intellect. You're going directly.
Right, exactly. Yeah. So, it's like, yeah, I mean, you could also have astrological interpretations, words, but the meat of the program is that sound. And you do it by dragging it. And so at different rates, it's kind of different aspects of the music are going to be emphasized, like, because, Jupiter is a much slower planet than all the others. So there's all sorts of possible variations with this.
See another couple of years of programming fun ahead.
Yeah, I do. Yeah.
Correlation between music and DNA. They're like with a single cell protoplasm that has 4 amino acids that make up the DNA. You can get like 4 tones out of it. But as the DNA gets more complex, the tones become more complex. And this guy was suggesting that Mozart and Beethoven were tapping in at that level.
Yeah. Yeah, I mean, music is, it just makes sense. That's all I can say. It's like,
But I'm wondering if you could make any correlations with this, with DNA. Like, could you build out a string of DNA molecules based on this?
well, DNA has information in it. I mean,
Just beginning to scratch the surface.
yeah, I'm sure you could. I'm not sure how exactly. Yeah, that's going in the other direction. We're going out into space. You're going into inner space.
We're looking for grand theory of everything.
I think it's in there. I do. I
Have
just,
you introduced Rupert Sheldrake to this your model here?
have I what?
Introduce Rupert Sheldrake.
I would love to introduce Rupert Sheldrake. If anyone knows him, I want his number.
I don't think he's in some way get something.
It's harder than you would imagine to get in contact with people. I've tried, and I'd love to get into contact. I'd love to talk to Neil Tyson DeGroote or whatever that guy is.
Well, he would be interested.
Any of these guys, any of those guys, I would like to show them this. But
Neil deGrasse Tyson.
Neil deGrasse Tyson, yeah. So yeah, there it is. That's our new development. I think you've seen most of it.
Yeah.
And we now have you can, if you don't have iPhone, you can download this on Android. Thomas just got that worked out.
Can you do this
So-
on, is it for iPad yet?
Works on iPad. It's beautiful on iPad.
Yeah, 'cause
It's gorgeous. Yeah, it's even better actually. Yeah. So yeah,
Not ready for Windows.
Windows. No, we need I want a version for the. I mean, can you imagine this full screen on this thing? Wouldn't that be something? Yeah, but yeah, we don't have a version for like a standalone computer yet. But something I'm wanting to do.
Pretty doable, it's just layout stuff.
Where
Yeah,
do I find it on my Android?
go to Android Play
Uh-huh.
and just look up Monad Calendar Clock.
I have
Thanks for the presentation.
Thank you, guys. You made this great.
Thomas is part of this. You're an inner spirit.
Thank you, Mariah.
Yeah, beautiful.
Yeah.
Thank you for showing up, man. You don't know what it means to have somebody in the audience. Yep, very grateful.
We didn't understand everything you said.
Everyone's got a book, right?
No, I didn't.
You don't have a book? Yeah, not.
I can't do it, or?
No.
Great, thank you.
Yeah.
It's a great read.
Is it not?
Yeah.